The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone, and welcome to today's AMCA Insight webinar, Positive Pressure Ventilators, PPV, and AMCA 240 updates. I am Lisa Cherney, the Education Manager for AMCA International, and I will serve as the moderator of today's webinar. Before we get going with our few housekeeping notes, there is one special announcement I'd like to share with the audience. AMCA is hosting their annual Idea Exchange meeting. It will be virtual this year. It's being held on April 13th. It is a half-day meeting, and the topic is the strength of I, impact, innovate, involve, and ignite. Details and registration for this half-day virtual event can be found at amca.org/idea. And we invite you to join us. We have fabulous speakers lined up. We have great topics to address, especially in this era of phenomenal change that we've all been going through, and great ideas that we want to communicate back and forth. So please go to our website and check that out if you're interested. Quick introductions and guidelines. The audience is muted during the webinar. Questions can be submitted at any time for our speaker via the control panel on your screen. If you go to the questions box, type in your question, hit send. We will address all of those at the end of the program. The webinar today is being recorded, and that recording will be available within 24 hours on the AMCA website. And if you are interested in earning PDH credit for today, please remember that you must stay on the program for its entirety, and you must also complete the evaluation that will be sent to you after the conclusion. Again, to submit questions, please use your control panel, and we will get to those at the end of the program, in addition to any questions that people submitted in advance on the registration form. PDH credit is being made available through AMCA International's involvement with our CEP. We have met the standards and requirements of our CEP, and a certificate of completion will be sent to everyone within 30 days of the end of this program. Content today is not being endorsed or approved by our CEP. And a quick disclaimer that the information in this webinar today is provided by AMCA as an educational service only. It is not intended to serve as professional engineering or manufacturing advice. The views and opinions expressed are entirely those of the speaker and do not necessarily represent the views of AMCA International. So in making this activity available to members and other professionals, we are not endorsing, sponsoring, or recommending a particular company, product, or application, and under no circumstances, including negligence, shall AMCA International be liable for damages arising out of any party's reliance upon or use of the content contained in the webinar. The program is copyrighted by AMCA International, so reproduction, distribution, or use of the materials without written permission is prohibited. So the boring stuff is over. Let's get to the fun part of today's program. Our presenter today is Kyle Weinmeister. He is the International Sales Director for an AMCA member company. Kyle has a bachelor's degree in mechanical engineering. He has an extensive background in business manufacturing, research and development, production, and customer satisfaction programs. And he has 2 years of volunteer firefighter experience. So he brings a very specific and unique perspective to today's program. And with that, I will turn the program over to Kyle.
Thank you, Lisa. Morning, everyone. Afternoon, evening to some. Thank you for joining us with this webinar. Looking here, we have 4 principles that we're going to try and hone in on by the end of the presentation. You should be able to explain and understand what entrained or induced airflow is, explain and understand what back pressure is, describe how and why AMCA 240 benefits firefighters, and identify an AMCA certified PPV on the AMCA website. With that, we'll start the presentation. Going a little too fast already. I'd like to start off with a brief history of firefighting ventilation to give us some context as to what the AMCA 240 does for firefighters and why it was created. So before PPVs, there were negative pressure ventilators. You can see a couple of examples on the right here. In about the 40s and the 50s, firefighters began repurposing boat and airplane propellers as non-permanent equipment to evacuate smoke from buildings so occupants could re-enter. They were difficult to set up. You had to prop them up in windows, find a way to set them indoors. They were just generally a little difficult to handle. They were also often electrically supplied, which produced more tripping hazards as generators were strewn out to supply these ejectors with power. Then in the 1970s, controlled airstreams began repurposing some movie production ventilators for use on the fire ground. So you can imagine one of those end scenes with their hair blowing in the wind. So firefighting industry actually got that idea from the movie industry. It took a while for the adoption of PPVs to really grab hold. Began in the West, and then by the 1990s, it had been gradually moving through the US, and by the mid to late 1990s, nearly all the US departments were training on PPV tactics. There were some major benefits, one being that the setback distance. As you can see in the bottom right picture, the fan was not directly flush with the doorway window, so you had some room to work. It also benefited the airflow by including entrained air. Another benefit was it was faster and easier to set up. You could roll the fan to the scene, set it where you would like it, start it, and leave it. Wasn't without skepticism that PPVs took hold. Early on, there was ideas that you would feed the fire with one of the three components of a triangle, which has now become a tetrahedron in the fire service. On the upper right-hand corner, you can see the tetrahedron, and oxygen being the part that PPVs would enhance. Through this skepticism, fire services have realized that it's very important to have water on the fire and a flow path established before beginning the ventilation. In the early days, the idea was to seal a doorway. You would take a PPV and position it until bidirectional flow was inhibited. As you can see on the right, let me move my cursor here so I can see what we're talking about. On the right, we have a picture that explains bidirectional flow. On the top, you have the hot gases, and in this case, even flames, coming out of the top portion of a doorway, a neutral plane, and then oh, thank you, Lisa. Got a laser pointer here. So the neutral plane here in the center, and then fresh, cool air coming in low. As you can imagine, this front firefighter, he's feeling the heat. His helmet is toasty. That's because the hot gases from the fire are coming out of the structure on top, and this is why the firefighter in the rear is staying low next to the cool, clear air. Later, it was found that stream conditioners could improve airflow. What they would do, instead of preventing bidirectional airflow, which was to some degree inevitable in larger structures, instead the idea was to push through in the bottom half of the structure. This created a more effective airflow. It also aided in ventilation through complex structures, created a higher pressure within the structure that allowed the smoke to be pushed through to the exit. It also allowed farther setback distances with sealing the doorway and round guards. Typical setback distances were about one doorway or one door length away. You can imagine 6, 7, 8 feet. With these new Airstream conditioners, that distance was extended up to 15, 16, 17 feet to allow more room for the firefighters to work at the entrance of the structure. There we go. Electrification. Shortly after the PPVs were being introduced, there were concerns of firefighters getting higher than normal rates of cancer. They started measuring carbon monoxide levels to be higher than normal or higher than allowable during the overhaul stage. Overhaul stage is when the main fire is out and you're searching through to make sure that all the little fires are put out within the structure. Ideally, you only show up to a fire once as a firefighter. It's not ideal to have to show up twice to the same place or sometimes even 3 times, but fires have a funny way of hiding inside walls, inside attics, and so the overhaul stage is meant to prevent any kind of flame up after. So during this time, firefighters were measuring high carbon monoxide levels and therefore found that gas PPVs and gas ventilators were contributing to this. Electrification still continues to this day for benefits outside of low emissions. They produce much less noise and there are less maintenance. You don't have to check the oil, fill up with gas, things like that. In the mid to late 2000s, we started seeing battery PPVs coming onto the scene. For a long time, they were not usable. Weight was too high. They were bulky. They weren't reliable. Runtime was very small. With the addition of lithium-ion battery technology, it's really changed the reliability, first of all, but also the size of what these PPVs are and the amount of weight. As you can see on the right, it's fairly simple for a single firefighter to carry a PPV on their shoulder up a stairwell or even just slide them along the stairs. Nowadays, battery PPVs are generally accepted for certain applications. This slide is meant to reiterate that it's important to stay current. A lot of these tactics are constantly changing. One good example of that is the fire development curve to the right. You'll see that in the past, firefighters were taught through the 4 stages of a fire. It's now understood that many of the structures are experiencing something closer to the bottom picture there, where the fire is ventilation limited. And then when fire department opens a door, vents, breaks a window, whatever it may be, they see an extreme rise in temperature, a very quick rise in temperature. And then this illustration over to the left here is from Paul Combs. He's a former firefighter, does really good work with portraying a firefighter's view and hitting home some of these ideas. Now I'd like to transition into the AMCA 240 standard. AMCA has created a video to promote the AMCA 240 standard, and we're going to use that as an introduction into the next part of this presentation. Thank you, Lisa. So hopefully that gives you guys a brief overview of the AMCA 240. I'd like to go into a little bit more detail on each of those. So in the beginning, why was the 240 created? So in the 80s and the 90s, there was a Wild West era for approaching airflow performance of PPVs. What was created was a positive feedback loop, and what happened is manufacturers' self-reported airflows were elevated through different methods. Fire departments would then receive that information from manufacturers and demand or specify the requirements of their airflows, which in turn made other manufacturers match those reported airflows. It was negative for everybody. Really, it was a deteriorating situation. So that something had to be done. So in 1996, a group of manufacturers came together and came to AMCA and said, we need to create this standard. We're having these issues, and I think you guys are the right partners and have the scientific background on how to make it happen. So what they did is they created the AMCA 240 standard, which included entrained air. 96, for a little context, was the first year that Calvin and Hobbes didn't actually produce anything, but just started selling everything. So this is a fun little cartoon there. So what is the AMCA 240? 210 was the base that 240 was built off of. 210, you can see over here on the left side, on the outlet of the fan, you can see that it's sealed. And through that, you have a curve generated. The problem with PPVs is you don't have that seal. There is no exhaust seal. And so what they came up with is here on the right, and you can see that there's a setback distance from the doorway to the PPV. There's a tilt that says where that PPV is pointed, and this allows the entrained air to be measured. Behind that wall, the doorway, this is what we're looking at here on the left. It's called a nozzle array. It allows AMCA to precisely measure the airflow going through the doorway. It's a very accurate, repeatable way to measure airflow. It's used in high-rise buildings, HVAC systems. It's really the standard on how to make airflow measurements. On the right, you'll see the diagram within AMCA 240 standard. Here you see the fan. It's placed at a setback distance of S with a tilt of, we've been out of school for too long. Maybe that's phi or theta. And a height of H. Here in this plane is where you would see the doorway. You effectively have a large room to settle the air so that laminar airflow can be measured. The nozzle array, seen here on the left, another large room, and then a variable exhaust system. The variable exhaust system pulls air through this chamber to allow variable back pressures. It's what makes the curve and allows AMCA to measure accurately at zero back pressure. So what is back pressure? Here we have a little bit more simplified drawing of the AMCA 240 setup. Back pressure is the difference in pressure between the inside and outside of the doorway. It's what reduces and increases airflow. So as back pressure increases, airflow will decrease. As back pressure decreases, airflow will increase. And that's what this fan is doing, is changing its speed to pull air at different airflows and affect this back pressure in this chamber here. So why was zero back pressure chosen? In 1996, there was little research available and an exact number was not known. Continuing research shows that zero back pressure is actually pretty common on the fire ground, especially when ventilation begins. So following the water on the fire and a flow path or the exhaust opening established, negative pressures can be realistic, and near zero back pressures are also realistic. Next, we'll look at entrained or induced airflow. Entrained airflow, as the video had described, is the airflow that does not go through the shroud. However, it is pulled in through the doorway. This effect comes from a law in fluids from Bernoulli's equation. It's that faster air has a lower pressure and slower air has higher pressure. Firefighters might experience this through hydraulic venting. So as you can see in the bottom left corner, someone's hydraulically venting through a window. The airflow generated from hydraulic venting is entrained airflow. By the water carrying some air particles or some air through that window opening, whatever it may be, it's pulling other air with it. And that's the concept of entrained air. There's a balance on the setback distance on how to get effective air through the doorway while maximizing the entrained air. Certain tests have found that roughly 15 to 12 feet behind the door is most effective at zero back pressure for the newer technologies, the newer front guards that are coming out from most quality PPV manufacturers. This is some test data that AMCA provides to the manufacturers. It's not reported on their website. So if you are interested in this kind of a report from your manufacturer, you can always request that. What they give is, unfortunately got cut off, but here on the bottom of the graph is airflow, and the y-axis shows static pressure, also known as back pressure. How the measurements are made for AMCA 240, there's 5 measurements in positive back pressure, meaning that you have lower airflow, and there's 5 matching measurements on negative back pressure, which is increasing your airflow. You're effectively pulling the air through the doorway. So for this curve that is matched as a best fit curve for all 10 points, manufacturers report this single value at free air. The reason that that's done is it's very difficult to have the test chamber at exactly zero back pressure. The reason behind this is we're talking extremely low pressures. As you can see over here, 1 psi is equal to about 6,900 Pascal. We're at 25 Pascal, which is roughly 0.0036 psi. So it's a special pressure transducer that was necessary to create this setup and allows AMCA to effectively and accurately measure 10 different airflows at very low pressure changes. Also in the test report is this table. You can see that the name, model number, the diameter, and some of these setup parameters, setback distance, tilt, and centerline height are reported. These are necessary to report on AMCA's website per their CERP program, which I'll talk about later. Only certain variables are necessary so that it's easily understood by the end user. We don't expect everybody to dig through this table of data and try to understand what the airflow is. So we The group at AMCA 240 is attempting to make this easily digestible and provide only one single number at free airflow. So the AMCA 240 is going through a review right now. Every 5 years, there's a committee that reviews the standard and makes sure that it's up to date. I'm part of that group this year, and we've been discussing how to include battery PPVs into the standard and how to effectively measure those. One way of doing that is by using a DC power supply. This gets away from any kind of AC power as well as any kind of battery power. The reason behind this is that battery power can be extremely good for a short period here in this curve. However, a majority of their power level will be on this portion of the curve, which is called the nominal voltage. So what we're trying to do is test these battery PPVs at their nominal voltage to exclude any of these large curves in the front or the tail end of the battery's life. What we're also doing is creating a supplementary runtime test. The reason behind that is you can imagine there's a certain amount of power in a battery. Manufacturers can choose to dump all that power really quickly, or they can meter out that power as they see and extend the runtime. So if we're going to measure airflow performance, then we'd also have to measure runtime to make sure that the manufacturers are not, so to say, turning the dial on their equipment. We're also looking at how to best report that in our test reports. Still haven't come to any conclusions on that. Hopefully in the near future, we can have some more traction and find a good solution. The other thing that the group is doing is looking at a different doorway size. In the past, we had used an 80-inch tall doorway, 36 inches wide. In an effort to include international partners and manufacturers, we're changing that doorway so that it can be repeatable in other continents, therefore allowing more people to be AMCA certified and have that access. So the AMCA 240, how does it benefit firefighters? First and foremost, AMCA certified PPVs are publicly available. If you go to AMCA's website and you find the tab called Certify, Certified Product Search, and then Positive Pressure Ventilator, you can find a list of manufacturers that are certified. Click on any of those manufacturers and you can find a list of the ventilators that they've certified. If you can't remember how to do that, simply search Positive Pressure Ventilator and it'll pop up. This allows the end user to double check, keep the manufacturer honest, make sure that the data sheet, the spec sheet that's been distributed matches what's publicly available on the AMCA website. This creates a group of standardized results. You can see up here on the top right, there's a number of standardizing groups, a number of acronyms out there that do standardizing: NFPA, ASME, NIOSH. Ventilators don't really fall in any of those. So we believe that it's best for a third party to standardize the results and make those commercially available, publicly available to the end user, the firefighter. And finally, they've been established for over 100 years. They got their start in kind of the same way. A group of HVAC companies got together, decided to make a standard, and it's all history from there. But they've been a long-term partner that's trusted in the HVAC industry, and we hope to utilize their benefits. This question was submitted during one of the registration, and how do you find the best PPV for you? It's a good question. It's one most firefighters are most interested in. So I'll just kind of run through the logic there. So what kind of space do you have? What compartment are you fitting a fan into? That should be step one. How much space? After that, you can start looking at different options. Do you need a gas-powered fan? Could you fit 2 battery fans in the place of gas-powered fan? Maybe you like the water-driven technology because there's no emissions and you already have your hose laid out. Whatever that may be, this would be a good time to decide on what is powering the fan. Next, initially you think, maybe how much air do I want? And I think I can safely say that the more air, the better. If you can get people back into their house, if you can get firefighters back to the station and cleaning their equipment faster, that's good. So the more airflow, the better. Now, having said that, you want to compare apples to apples. Can't compare an AMCA certified airflow that's been third-party tested and is publicly available to something like according to AMCA 240 or another version that is that has been out there in the industry. AMCA certified values are found on AMCA websites. Certain manufacturers make those available in their catalogs as well. However, there's also an uglier side that says according to AMCA 240 or something thereof. It's basically saying not tested through, well, it could be tested through AMCA 240, but typically they're not. And you can imagine somebody saying, as you're receiving, you're doing the final checks on your truck, and the manufacturer says, oh, by the way, this is mostly NFPA compliant. In your mind, that's not NFPA compliant. So this is something similar. A trick I use is, how many zeros can you count on the end of an airflow? The more zeros you see, the less likely it is lab accredited. It's tested in a technical setting. So be sure to compare apples to apples when making measurement comparisons. Finally, kind of the extras, features and accessories. Mister, do you want a mount in it with your truck? Once you've found the right fan, then that should kind of aid in the decision process. Hopefully that helps you guys. I'd like to end it with some good resources. UL's Firefighter Safety and Research Institute, their team has been very good at pushing the way in providing open and easy information for firefighters about certain situations. You can see here on the right, they build a structure, they wire it up, they put pressure transducers, they put thermistors, they measure everything that they can, and then they burn it down. Not always do you get that opportunity. This series of pictures to the right is from their effectiveness of fire service positive pressure ventilation. You can see that it's got a lot of wires going to it, and they actually burn it down. Their team's been really good. They do a number of good things. They're honing in on what a coordinated attack needs. That's the balance between positive pressure ventilation and positive pressure attack. Kind of honing in that you really need water on the fire before you start ventilating. You need to have some kind of flow path. And actually, the high-rise buildings, I mistakenly put this under UL's headline. However, the high-rise buildings and how to positively pressure stairwells came from the NIST study. So my apologies there. Both websites, NIST and UL, have publicly available reports that you can read. They're a little bit lengthy, so be ready for some reading, but they have a lot of good content if you want to dig into it. Also, what UL's team is doing is promoting the reduction of back pressure. It's kind of commonly thought that the exhaust or the outlet of the flow path should be about 2 times larger than the inlet. UL did a study that measured the airflow when the outlet is increased, they stopped at 5 times larger than the inlet and found an ever increasing airflow. So my takeaway is that if you need more airflow, increase the outlet, the exhaust of that flow path. It's not always feasible in every situation, but if airflow is the critical path, then look at extending that exhaust opening. If you're coming from Europe or across the pond, Stefan Svensson, sorry Stefan if I'm butchering your name, but he has a lot of good information out there, written a number of books and papers. He's from Sweden. He's a firefighter himself as well as a professor, and he provides a lot of good information about ventilation tactics, general rules of thumb. Really good resource over there. Obviously, I think is your regional fire instructors. They're going to understand your situation the best. They're going to take more into account than maybe your manufacturers, and understand that not every department has all capabilities. So I'd reach out to your regional fire instructor, and of course, trusted manufacturers of PPVs. We make equipment the best we can for firefighters, and we take a lot of input, a lot of questions from firefighters, and hopefully we have answers. If we don't, we should be looking to find those answers for you. So that kind of wraps up my presentation. That gives us a little bit more time than I had planned for questions and answers. If we want to start that, perfect.
Sure. So thank you, Kyle. We'll move on to Q&A. Before we get to that point, I do want to let people know that if you are looking for PDH credit for today, please don't forget to complete the survey at the end, and those credits will be issued within 30 days. So Kyle, what do you say that we let people see us so that they know we're actually here live with them?
What do I say? I don't know. It's a beautiful day in Colorado, I guess.
Say yes and turn on your camera.
Oh, of course. My bad. There we are. Let's see if I can.
All right. Let me see if I can get mine working. If it's feeling, all right, it's feeling good today. So we have, just to remind everyone, if you do have questions to submit for Kyle, please go ahead and go to the questions box on your control panel and type that question in, and we will get to as many as we can. There are 2 advanced questions, Kyle, that I want to bring up with you. One question is, could you please speak about the use of mixed flow direct drive fans for use in ventilation systems?
Mixed flow fans are not the preferred type of fan that firefighters use. Seeing that question, I looked them up real quick. I wasn't familiar what a mixed flow fan was, and to my understanding, the benefits of a mixed flow fan come from reduced sound. And so in an industrial setting like a hospital, this makes a lot more sense, or a restaurant, school maybe. However, on the fire ground, sound isn't really the largest consideration. What we're trying to do, what a firefighter is trying to do, is get as much airflow through the building. It's already going to be extremely loud, and so the benefits of a mixed flow fan, to my understanding, wouldn't necessarily make sense for a fire ground. Doesn't mean that you couldn't test it on the AMCA 240 setup and have that report. Although, to my knowledge, mixed flow fans are not utilized by the firefighting industry.
Okay, thank you for that. And another question that we received, this person is asking, would this include, this being PPV, I'm assuming, stair pressurization fans and fans provided for smoke control systems?
Yes. Smoke control systems, if they're referring to permanent installations, then no. However, if you are talking about temporary ventilation, if you're talking about non-permanent setups, then yes. So PPVs are commonly used to pressurize stairwells in high rises or other apartment complexes. It's the goal to isolate smoke in a certain level or a certain room. And so the tactic is to pressurize the rooms around it and isolate the smoke and try to establish a flow path that allows the exit to smoke or exit most closely to the seat of the fire as you can. So, yes, it is used on stairwells. And if you ask for the test report, you may even find a more applicable airflow if you have a charged stairwell and you place a PPV at, say, somewhere along the high rise. You'll have a higher, you're having less back pressure fight against the fan. And so if you asked for the test report from your manufacturer, you may be able to better figure out what your effective airflow would be.
Okay, great. So we have a question that's come in, and this person is saying that the testing setup that you showed has an incline for the PPV to sit on and blow towards an open door. The incline is not very likely to be there in most real-world scenarios. So, does the PPV allow for rotating the discharge according to the incline used for the testing standard? And I, by the way, want to let you know, Kyle, you can take control and go back on slides anytime you want to.
Okay, let's see if I can get it to work here. All right, looks good. So, great question. First of all, great catch. That's a lesser recognized, and I think what they're referring to is this platform that's built onto the actual floor. What that's meant is to represent the floor of a house or some kind of balcony, stoop, whatever it may be, leading up to the doorway. So doorways are flush with the ground. For their setup, it was necessary to have the doorway off of the actual concrete floor of the lab. And so this runway, it's actually flat. It's not inclined at all. It's meant to represent the ground. And the idea there is that you don't want entrained airflow from below. You can imagine if this fan were propped up on a stand and there was a doorway across the room and there was no ground simulated in between, you would get an elevated airflow that would not be existent in reality. You want that ground to be there so that entrained airflow isn't pulled in from the bottom of that doorway. So the intent is to keep the test as realistic as possible with the real world situation that you would apply a PPV to.
Okay, great. Thank you for that. Another question that we have is, are all battery fans tested on battery power currently?
I can only speak for my company, and if you're interested, the test reports have many different photos. So we would be happy to provide the proof that AMCA gives to us as to how these fans are tested. It's hard for me to say for anybody else. I don't necessarily go to my competitors and ask for their test reports. However, if you're willing to reach out to your manufacturer and they're AMCA tested, then they'll have photos at the bottom of that test report that will prove to whoever is interested what the power source was.
Okay, good point. Maybe we could start a new trend of asking competitors for their reports for full disclosure.
Full disclosure, we're open for that. All right.
Yeah. All right. So you have talked a good amount about entrained air in your presentation. So this next question is on that topic. This gentleman is asking how much of the doorway, the cone of air from the fan should take up?
Okay.
What is the additional air volume gained?
Perfect. Great question. And it hits home on why there's new front guards attached to many of the latest PPVs. If the idea is to seal the doorway, then you're going to position forward and back until you reduce the smoke escaping from the top of the doorway as best you can. If the idea is to use these stream conditioners and really punch through the bottom half of the door, then what you're trying to do is really get a feel for how much wind is at your back if you're at a relatively stable state. So not a whole lot of wind. We would recommend 12, 15 feet. And what that's going to do is it's going to increase the air through the doorway approximately 1.5 to 2 times. And that's all laboratory settings. So this doesn't include external factors that you might see on a fire ground. There's a number of those that you can see. A short stoop in front of you, a raging fire versus grandma cooking the soup a little bit too long, and we're just trying to get the smoke out. So I'd ask that you reach out to your local manufacturer or local fire instructor if you need more direction on how to set up a PPV.
All right, great. Thank you. So does PPV help the fire spread or get stronger due to pushing fresh air or oxygen into the area?
If there's no water and you are putting ventilation before any kind of handline is established within the structure. So most recently, the studies say that you should really put water on a fire before you start ventilating. What that does is it reduces the overall heat of the fire and it prevents it from moving too much. Although they are correct that adding more air to a structure can increase the fire's strength and make it move towards the exit usually. It's one reason that communication is very critical between the hose team and typically a ladder team or a truck. Communication is critical. If you're trying to find the seat of the fire and you're crawling through a window and you're creating a flow path and then somebody turns on the fan, that's a very dangerous situation because that fire will find an exit, which is the window that the firefighter just crawled through, and move towards that exit. It can change the environment very quickly for the firefighter inside and should be avoided at all costs. It's one of the main reasons that UL's Firefighter Safety Research Institute is looking at the timing and the coordination and trying to hone in on what is PPV versus PPA.
All right, very interesting. And while we're on the topic of airflow, let's go with this question that just came in. So this gentleman said that, Kyle, you mentioned needing to figure out how much airflow you were wanting. The connection between building size and airflow being relevant, at what size building do you start to consider higher airflow or fan size?
Good question. Little open-ended, which I kind of like. The other thing we're looking at AMCA 240 this revision cycle is it necessary to limit the size of ventilators that can be tested? What we came up with is no, you don't. It's up to the manufacturer. However, this is a standard designed around a single person doorway. If you're looking at a double door, if you're looking at a garage door, if you're looking at a dock and you can open multiple docks, then what you're going to do is not directly applicable to the AMCA 240 test. It's difficult to define large ventilator. I think the industry's kind of honed in around 24 to 30 inches as the largest size of ventilator that you can consider to be carryable by 2 firefighters. And so what we've begun doing is trailer mounted ventilators, and that's a different ballgame completely. You're not looking at entryways. You're really more concerned about how fast you can get people back to work, typically in industrial settings.
Okay, that's interesting. Thank you. And on the topic of AMCA 240, we have a question. People would like to know, when will AMCA 240 be available that takes battery fans into account? Is that something happening maybe later this year, or is that part of the 5-year off cycle?
It will be happening in this cycle. When is a good question. How many comments we receive and how many cycles it needs to go through before it gets approved. I'd love to say it's going to happen in 2021, but I'm not the only person that decides that. And so it'll really depend on a group, and hopefully we can get that out sooner rather than later, so that these tests can be more applicable for the firefighters using battery PPVs.
Okay, great. And I want to backtrack a little bit, because I think this is a really good high-level overview question. Can you once again review, Kyle, how PPVs extinguish fire while simultaneously providing oxygen?
Okay. PPVs will not extinguish the fire. So a good idea, or something that I've been taught, I guess, is the difference between a hurricane and a cold front. So a hurricane is a lot of violent air. It's really churning. That's kind of like a at the doorway of a PPV. You put your hand there, you do a pant leg test, and you're saying, man, that air is moving fast. It must be moving 50 miles, 60 miles an hour. What happens throughout the structure is that air gets slowed down as the area increases. So your airflow is the same, roughly, but the air speed is reduced. And so the idea behind positively pressurizing a structure to effectively ventilate is beneficial outside of fanning the fire. You are going to fan the fire slightly, but it provides a more tenable space for victims. It's more easily, firefighters find them easier. It's easier to navigate through the structure, find the seat of the fire. That can be one of the largest complications when trying to find somebody, is simply getting lost within a structure and keeping that space with some fresh air so that the victim can stay alive longer and be found. You are making a compromise. To some degree, yes, you are fanning a fire. But as I spoke about earlier, you really shouldn't be ventilating before the seat of the fire has been found and water is being put on the fire. If you're ventilating before a hose team or a hand line is going into the structure, you might reevaluate how you're communicating and making sure that everybody is on the same page, and that the IC is really doing a good job at timing the ventilation with massive amounts of water being put on that fire, and trying to get it under control, and lessen the ventilation limited and more on the heat limited side.
Okay, very good. We have a question that is coming from what I think is obviously a professional in the firefighting arena. This question is, what can we use at our department to test other than the paper in the window?
Yep, paper in the window, ribbon in the window. Those are good tests. What we've started to try and make this test mobile, let's call it, and have it tested within their own structures. We would suggest an anemometer, which is the technical term for a wind speed monitor. They're handheld monitors, they're relatively inexpensive, and you can more accurately read what the airspeed is. And then you can make a couple of different measurements. So this is your window. Let me get the angle right here. You don't always want to, man, I really can't get the angle right. So you don't always want to measure it just right there in the dead center. What a best practice would be is to measure maybe 1, 2, 3, 4, 5, 6, 7, 8, 9 points, average those, or however you guys want to do that. But I would recommend a wind speed meter, and then to kind of do a traverse along a window or an exit of any kind to test within whatever structure you guys were interested in. Good stuff. Good question, though.
All right. We're coming close to the hour, so I'm going to give you one more question here. Is VFD required for staircase pressurization fans?
I'm taking that as a VFD is it's either a volunteer fire department or maybe a variable frequency drive. So I think what they're talking about is a variable speed ventilator. Is it necessary for a stair pressure? The reason I think that this question is being asked is so that there isn't an excessive pressure buildup in the stairwell that any kind of people that are trying to escape, they don't get trapped behind a closed door because there's too much pressure on the backside. And so, although that is possible, it's from my understanding difficult to do. And actually, I'm not that informed, I guess, on how much pressure it would take to prevent somebody to open up a door. I might have to follow up with that person following this presentation, because I don't know exactly how much force that's going to take and what the pressure would be. So I could do a quick calculation though and get back to them if they would forward me an email.
No problem. No problem. Thank you for your willingness to follow up on that. And for anyone who submitted a question that we did not get to, please know that we will follow up with you in the next week or so with some information from Kyle, some answers. We do have Kyle's phone number available here. He has generously agreed to make himself available if there are extended questions beyond today's presentation. As mentioned at the beginning, the PDF version of the presentation is available in the handouts section of your control panel, so you can download that. And we, again, will also be posting that on the AMCA website within 24 hours or so you can access it there. Kyle, I want to thank you for your time today and your expertise. This has been a great program, and I think everybody has benefited from it. Letting the audience know, we do have another webinar a week from today. It is Wednesday the 31st, 12 to 1 p.m. Central Time, same place. Impact of duct fitting selection is the topic, and our presenter will be Mr. Pat Brooks from SMACNA. He is their senior project manager. So if you have not registered for that, please do so. And one more mention of the upcoming April 13th AMCA Idea Exchange. There is a downloadable brochure in the handouts section of your control panel. And if you go to amca.org/idea, you can also access the brochure, the program information, registration details, and fees for this awesome event that we're hosting virtually in 2021. So Kyle, thanks again so much. We hope to have some good follow-up on this and hear more about AMCA 240 coming out in the very near future.
Thank you, everybody, and stay safe out there.
Thanks, you too.